Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Aisyah binti Muhammad Noor. My metric number is 19101057 I from RK05 Microelectronics Engineering Year 4. And today I will explain about the depletion mode of Mosfet. The metal oxide semiconductor field effect transistor or Mosfet is a voltage control device that construct with terminal like source, drain, gate and body to amplify or switch voltage within circuit and also extensively used in integrated circuit for digital application. These are also used in analog circuit like amplifier and filter. Depletion mode of Mosfet. A Mosfet that normally turns off without applying any gate voltage when you connect is known as depletion mode Mosfet. The flow current is from the drain terminal to the source. This type of MOSFET is also known as normally on the device. Once a voltage is applied at the gate terminal of the MOSFET, the drain to the source channel will become more resistive. When the gate source voltage enhances more the flow of the current from the drain to the source will reduce until the flow of current from the drain to the source stops. There are two types depletion mode of MOSFET, which is N-channel depletion mode and also P-channel depletion mode. So for N-channel depletion mode, in this type of depletion MOSFET, the source and the drain are connected by a small strip of N-type semiconductor. The substrate used in this MOSFET is a P-type semiconductor, and electrons are the majority charge carrier in this type of MOSFET. Here, the source and drain are doped heavily. The N-channel depletion mode MOSFET construction is the same compared the enhancement mode in N-channel MOSFET except its working is dissimilar. The gap between the source and the drain terminals is composed of N-type impurities. When we apply a potential difference between both the terminals like source and drain, current flow throughout the whole N region of the substrate. When a negative voltage is applied at the gate terminals of this MOSFET, the charge carriers like electrons will get repelled and move down within a region under the dielectric layer. So, charge carrier deflection will occur within the channel. Thus, the overall channel conductivity get reduced. In this condition, once the same voltage is applied at the gate terminal, the drain current will be decreased. Once the negative voltage is increased, whether it reach the mesh of mode. Let's talk about N-channel depletion mode characteristic. Firstly is drain characteristic. These characteristics are plotted between the VDS and IDSS. When we keep on increasing the VDS value, then the ID will increase. After a certain voltage, the drain current ID will become constant. The saturation between value for VGS equal to 0 is called IDSS. Wherever the voltage applied is negative, and then this voltage at the gate terminal will push the charge carrier like electron to the substrate. And a so hole within this p-type substrate will be attracted by this electron. So due to this voltage, the electron within channel will recombine with hole. The rate of recombination will depend on negative voltage applied. Once we increase this negative voltage, the recombination rate will also increase, so which will decrease the number of electrons available within this channel and will reduce the current flow effectively. When we observe the above characteristic, it is seen that when the VGS value becomes more negative, then the drain current will decrease at a certain voltage. This negative voltage will become zero. This voltage is known as pinch off voltage. This MOSFET also work For the positive voltage, so when we apply the positive voltage at the gate terminal, then the electron will attract with n channel. So the number of electron within this channel will increase. The current flow within this channel also increase. The positive VGS value, the ID will be even more than IDSS. Next, we will move to P-channel depletion mode. In the P-channel depletion MOSFET, a small strip of semiconductor of P-type connects to the source and drain. The source and drain of P-type semiconductor and the substrate of N-type semiconductor. The majority of charge carrier are whole. The p-channel depletion MOSFET construction is quite opposite to the n-channel depletion mode MOSFET. These MOSFETs include a channel that is made in between the source and drain region, which is heavily doped with p-type impurities. So, in this MOSFET, the n-type substrate is used and the channel is p-type as shown in the diagram. Once we apply a positive voltage at the MOSFET gate terminal, then the minority charge carrier like electron in the p-type region will get attracted due to the electrostatic action and form phase negative impurity ions. So a depletion region will form within the channel and consequently, the conductivity of the channel gets reduced. In this way, the drain current is controlled by applying positive voltage at the gate terminal. To activate this type of depletion type MOSFET, the gate voltage must be 0V and the drain current value is large. So the transistor will be active in reactive region. So once more to turn on this MOSFET, positive voltage is given at the source terminal. So with enough positive voltage and no voltage applied at the base terminal, this MOSFET will be in maximum operation and has a high current. To deactivate a p-channel depletion MOSFET, there are two ways you can cut off the bias positive voltage that powers the drain. Otherwise, you can apply a negative voltage to the gate terminal. Once the negative voltage is provided to the gate terminal, the current will be decreased. As the gate voltage turn more negative, the current reduces until cut off, then MOSFET will be in the off condition. So this stops a large source to the drain current. Once more negative voltage is provided to the gate terminal of this MOSFET, then this MOSFET will conduct less and less current will be there across the source drain terminal. Once the gate voltage attains a certain negative voltage threshold, then it turns off the transistor. So negative voltage turn off the transistor. Let's move to p-channel drain characteristic. The drain characteristic of p-channel depletion MOSFET is shown below. Here, the VGS voltage is negative and VGS voltage is positive. Once we keep on the increasing the VGS, then the ID, which is drain current, will increase. At the peak of voltage, this ID will become zero. Once the VGS is negative, then the ID value will be even higher than IDSS. For the transfer characteristic of p-channel, the transfer characteristic of p-channel depletion MOSFET is shown below, which is a mirror image of n-channel depletion MOSFET transfer characteristic. Here we can observe the drain current enhanced in the positive VGS region from the cutoff point of IDSS, and then it continues increase when the negative VGS value increase. So we will proceed with last but not least application of MOSFET. The depletion MOSFET application including the following, which is first, use the constant current source and linear regulator circuit as pass resistor. Second, extensively used in startup auxiliary power supply circuit. Third, used in digital logic circuit as load resistor. Fourth, used for flyback circuit within PWM ICs. Fifth, used in telecom switch, solid state relay, and many more. And last but not least, utilized within voltage sweeping circuit, current monitor circuit, lead array, driver circuit, etc. So I already explained about the depletion mode of MOSFET, which is N-channel depletion mode, P-channel depletion mode, drain characteristic of both channel, and also transfer characteristic. So I hope you already know about this depletion mode and understand for this part. Thank you.